Hi, my name is Samson, and now I'll be talking about RMI and Cobra in client-server computing. These two technologies were very important in early distributed system because they allowed different applications to communicate reliably. So, RMI focused on remote method calls for Java programs, while Cobra enabled communication across different programming languages. So, even though both are older technologies, they help form the foundation for modern distributed system. So, we have like web services and microservices. And then for RMI implementation part, so how RMI works, RMI allows a Java application to call methods that are actually running on another machine. It uses remote interfaces, stubs, skeletons, and a transport layer to manage the communication. The server registers the remote object in the RMI registry, and the client retrieves a stub to interact with it, so as if it were a local object. So this removes the need for manual socket programming and makes distributed Java development much easier. And then for the example part, I use a banking system. So the main bank server stores all customer information, while branch computers run team clients. When the officer wants to check a customer balance, the client calls the get balance method through the RMI. So the request goes to the central server, the server processes it, and then it results the return instantly. So everything feels local, even though the logic runs remotely. Next up, I'll be talking about Cobra adoption. So how Cobra works. So Cobra works differently because it supports different multiple languages. It uses an interface definition language or IDL to define the methods. So the IDL is then compiled into stubs and skeletons for each languages. The object request broker acts as the middle layer that handles all communication. This makes Cobra very flexible compared to RMI since it can connect systems written in Java, C++, and many others. And then for Cobra example, I use hospital system. So in hospital system, radiology might use C++ software for handling the medical images, while administration uses Java. By defining a method like get patient record in IDL, both systems can communicate each other very well. So the ORB passes requests from the Java system to the C++ server, and then it retrieves the data and returns it instantly. This allows the hospital to integrate their system without rewriting anything. So even though there are many advantages, like I said just now, however, IMI has clear limitation. It only works in Java environments, which is not suitable for modern systems that use many different languages. It's also heavily dependent on the Java virtual machine, making it less suitable for cloud platforms and container-based environments. And then for issue with Cobra, Cobra also has disadvantages like over time it became too complex, which made it harder to maintain. Different vendors had different implementation, so the behavior was not always consistent. This communication model is also quite heavy actually compared to the more modern and lightweight approaches. So for the current state and modern replacement, this limitation led to newer technologies becoming more and more popular. The REST APIs gained dominance because they are simple, fast, and support all the platforms. So meanwhile, gRPC also introduced a faster binary with a better performance, like they have many strong multi-languages supports. So these tools fit better with cloud computing and microservices. So in the conclusion part, IMI and Cobra play an important role in the evolution of distributed system. So they introduce ideas like remote invocation and object transparency that we still rely on today, even though modern solutions like REST and gRPC have replaced them. Understanding RMI and Cobra helps us appreciate how distributed communication has improved over time. So that's all for my presentation. Thank you.